Hey there, Math 112 fans. If somebody's asking about this in the discussion board, my intention on Monday is to talk about this problem as well as similar ideas. But I thought I would just say a few things for those of you getting ahead on the homework, which I do appreciate. Just a few units things. So what we're learning, and we'll talk about this, and I probably will make more content, but we're learning how to go from the derivative back to the original function. So if you remember a few things, just a few general comments. If this were your derivative, let's pretend this is f prime just for a moment, and that's very similar to what MR looks like. We think of this in terms of slope. So I would challenge you now to think about what f of x looks like. Or in particular, if we call this MR, what does TR look like? So we learned a lot of general things, like the fact that this is positive and negative means this goes uphill and downhill. Now, in order to actually graph, you have to know where it starts, and that's that plus C business. So one thing we've mentioned already, but I want to recap, is total revenue at zero is always zero. Because if you sell 0 items, you make $0. $0 comes in. So initially, the slope is really steep. That's what this means. And then it goes up. Slope gets less and less, and then the slope is 0 right here. That's what we've already learned. And then it comes back down. It's negative here. So we've been thinking about that, but mostly we've been thinking about it this way, and now we're thinking about it the other way. But there's an added piece that we are just learning, which is that the area of this, whatever that area is the same as the height there. So whatever that point is. So in this case, it's at 7. So this is 7. So if I wanted to know the total revenue at 7, the visual way to see it is to think about that area. And in this case, that's actually really fast to do because it's 14 by 7. It's a triangle. So 1/2, 14 times 7. But it's just nice to have a visual to attach it to. Okay? So in this, if you want to just talk about this point for a second, we can say that in this direction, the slope is 0 there. Slope of the graph above is 0. In the other direction, we can say the area actually gives the value, and that completes the picture. That's the fundamental theorem of calculus. Okay, so a small couple notes about this problem. They also ask you about total cost, and so a few things about that. The total cost at 0 is not usually 0. It's what we call the fixed cost. They tell you what that is down here, but this is one of the notes I wanted to make, which is that if they tell you that the total cost is 500 and everything is in hundreds, there's a little, everybody's been just asking, people who have worked ahead have been asking me about this, but we don't do as much with units as we used to in this course when we did a lot of stuff with graphs. This is sort of a holdover from that, but I think it's something we can handle. If somebody says blank 100 things and then they give you blank $100 for fixed cost is blank $100, and then they tell you $500, you'd put a 5 here. So that in this case, they're telling you this is 5. It's just because the units are $100. Let me make my head a little smaller. Big fat head. Okay, so there we go. Other things here. Variable cost. Again, that's something that does come up in Math 111, but not everyone had Math 111. The variable cost is the same thing as total cost, except that it doesn't include the 5. So the reason it's coming up here is it's a chance for us to think about C. Yeah, the only difference between variable cost and total cost is C. Okay, so let's erase this. And I'm not going to answer the whole question. I think I probably will do this like as an entry task on Monday, but I just wanted to talk about, 1, make sure people get screwed up on this. 2, make sure you knew the initial conditions, which are these. And then lastly, to connect area. So now let's talk about marginal cost. This is just trying to give you things to think about. This is marginal cost. So think of this as the derivative. And let's think about what that means about total cost. In this case, the derivative is always positive. In fact, it's getting steeper. Now, the total cost starts at 5 and then goes up and gets steeper and steeper and steeper. That's what that's saying. The variable cost is the exact same graph, but it starts at 0. Doesn't include the 5. The gap between them is always 5. So that's what's going on. This is total cost. This is variable cost. And this is marginal cost. So there's some visuals of what's going on. You can do all this by estimating the area. You know, if you want, so we already did the area of a triangle. If you want to do these areas, you don't need to do any formulas. You could, meaning formulas for the lines. But you can also use just the area of a triangle and a rectangle. If you happen to want the area of a trapezoid, I'll give that to you because it's very quick to get. So let me explain how you get it if you ever needed to know it. So let's pretend, for example, that I want to do the area all the way to 10. I don't think the question asks that anywhere, but that you know that this is 2 and this is 6. Is that 6? Yeah. And this is 10. So if you don't know the area for that, there's actually a simple way to remember it. This is 6 by 10. You probably know the area of that rectangle. And here's another one. 2 by 10. So if I was in class with you, I would say, what are those areas? Well, the area of this rectangle is 60. The area of this rectangle is 20. The trapezoid, which is what we call that shape, is halfway in between those two. And that's how I remember the formula. If I need the formula of a trapezoid, I remember that it's halfway between the area of this small rectangle and this big rectangle. So it's basically 1/2 of 60 plus 20, which is 40. So that's the area of this. Now, if you want the formula is 1/2, and then it's the first height, sometimes we call this height 1, times the base, plus height 2 times the base. But most times when you look up in a book, the base is factored out. So it's height 1 plus height 2 times the base. So if you want to use that in this problem to help you, that's good. So in doing this, we can basically think of the graphs as separate. We can think of the total cost as the area, the variable cost as the area under marginal cost. The only difference for total cost is that you have to add 5. So briefly, this is just getting you to explore the following ideas. The variable cost at any value, let's just pick a number. How about 10? The variable cost at 10 is the area under the marginal cost, which we just computed. I know I went off the screen. This is just getting you thinking because we'll do this in class. And so we figured out that this was $100. Okay. So what about the total cost? The total cost is the same thing, but it doesn't start at 0. It starts at 5. So it's the exact same thing. This is just getting us to play around with this. We used to do a lot with this. Now we're just doing a little bit. Okay. That's what those are. The only other thing is, how based off of that could you figure out the profit? Well, the profit's going to have to do with what's in between here, if you think about that. So if you could find the area under MR, so the whatever that is at 5 where they meet, you could find the total revenue at 5 by doing the area under MR. And you don't have to add anything because it starts at 0. This is just getting you, this is the sort of game we're playing. You could find the variable cost at 5 where they intersect by estimating the area from 0 to 5 under MC. If you wanted the total cost at 5, you'd have to add in the $500. So those you can find. This is cool. We can do a lot more with this, but in this course, we're just giving you a light introduction. If you wanted the profit, you would do this minus this. So think about the question. Don't panic if you can't answer it right away. Discuss it in lab. I think sometimes students are like, oh, this homework question took me longer. But this is exploring these ideas. Okay. So we're not going to do a lot with graphs, but I do expect you to know that graph because it connects several things. So I just wanted to give that little precursor, and this problem will probably come up in lecture as well. But for those of you working over the weekend, I didn't want you stuck up based on that 500 issue. All right, let's leave it at that.